Okay, I kind of said this on the previous video, but just in case, I'm going to finish up my thoughts on this. So suppose you got f times d plus or minus g times e to equal b. So either the plus one or the minus one to equal b. So you found your pairings. Then a times x squared plus bx plus c equals the f of x plus or minus d times g of x plus or minus e. And whether it's you use the plus or minus on each of those, there's 4 possibilities for pluses and minuses there. And which one you use will depend on which one gives you the correct number b. Okay, so I just wrote that out here. The choice of plus or minus for each factor is made so that when we multiply the factored form out, we get the right signs in ax squared plus bx plus c. So we'd have to have the right signs for c and for b. And when we do this, we always have a positive. If a wasn't positive, we would first factor a negative out of all 3 terms. And then inside that, we'd have a positive a. And so we would do this with that. That's just to cut down on possibilities. So you don't have to do plus or minus f and plus or minus g and have too many things to check. Okay, so if none of these work, then there's no solution. So finally, let's get to an example. And I'm starting with one of the simpler examples just because everything is plus. If everything is plus in your trinomial, then everything will be plus in the answer here. These will both be plus. So that makes the ones with all pluses the easiest ones. Out of the ones with a leading coefficient that's not 1, those are the easiest ones because everything's plus. So I wrote down 10 and 6, that's A and C, and then between them I write plus because 6 it's plus 6, right? It's plus 6, and so I write that plus in front of the 6. And this means when I do these products, I'm going to add them. Okay, so ways of factoring 10. 1 times 10. I always start with 1 and then just go up the factors. And then when you get high enough, they'll start repeating. So 1, 10, 2, 5. If I tried to get the next highest factor would be 5, 2. And so it's repeating, so I just stopped there. 6 can be factored as 1 times 6 and 2 times 3. And I'm not including the negative ones here. You could, it's just that you'd have twice as long as a list, and that would make everything a lot more things to check, so we just don't do that. So I'm going to try these two and see if those products, so I'm taking 1 times 1 plus, right, 1 times 1 plus 10 times 6. Well, that's 61. That's not nowhere near 19. Okay, I'm trying to get 19. So that's wrong. Now I would try crossing these, and I would say, okay, 10 plus 6, right, plus. 10 plus 6 is 16. Well, that's pretty close, but it's still not 19. So this pair doesn't work with this pair. So then I try this pair with this pair. And I do them parallel, and I do them crossing. Parallel, 30 plus 2 is not 19. Okay, crossing, 20 plus 3 is not 19. Remember, I'm adding because of this. So these two don't work with these. So therefore, this doesn't work with any of these. So I'm hoping it's these two. If these two don't work, then there's no solution. I mean, there's no factor. It doesn't factor. So I try these going straight across. And you get 2 times 1, 5 times 6. So that's 2 plus 30. That's not anywhere near 20. And then if you cross them, you get 12 plus 5, which is 17. That's close, but not quite right. So these two don't work with these two. And I move down to these two times these two. And I go straight across. I get 4 plus 18. No, 4, I'm sorry. 4 plus 15 is 19. Bingo. So I would write in these ones. These ones I wouldn't have written. I would have just done them in my head. So I would write in these two, and those are the combinations I need. Then I'll show you what to do with them. Now I'm going to write out everything that I just said, but I just wanted to show you it's not that hard. Once you know what you're doing, you don't have to write a whole ton of stuff. Okay, so this is the idea. So if in case you forget what I was doing, you can look at it later. So I'm doing 1 times 1 plus 10 times 6, and I'm seeing, is that 19? Nope. I don't care what it is. If it's not 19, then I don't care what it is, right? And then I cross them, and I get 1 times 6 plus 10 times 1. That's not 19. That's actually 16, right? And then I just drew this again because it was getting messy. I usually wouldn't do this because I wouldn't usually write in all these. I don't write in all these lines. I just write the ones that the final one that works, right? And again, as soon as you get to one that works, you stop. So here I've got 30 plus 2. That's not going to be right. It's not going to be 19. And then I try crossing them, and I get 10 times 2 is 20. Then I'm going to add 3. That's bigger than 19, so that's not right. Right? And then so that eliminates 10 times 1 for the coefficients of x squared. Or, will be coefficients of x. So then I try these. Doesn't work. Tried those. Doesn't work. Right? And then the final pairs are these. So I only have 2 possibilities left. The other one is with these 2 crossed. So, 2 times 3, which is 6, plus 5 times 2, which is 10. That would be 16, which is not 19. So you have to go this way. This is the way that it works. And that actually worked. So I stopped there. Yay! I had to do all of them but one. Now, sometimes you just, with a little practice, you can just look at these and you can see which ones to use right away. Sometimes you don't, and that's when you have to be systematic like this, is when you don't see the one. Now, if the middle coefficient is kind of smaller, then you'll tend to be using the ones towards the bottom. If it's a bigger number, you'll tend to use the ones towards the top. But what is small and what is big depends on what these 2 numbers are. So that's just sort of a real basic rule of thumb if you're trying to skip these steps here and find the answer quicker. So I would have tried these 2 first, probably, just to see if they worked. Okay, so I know I'm using 2 and 5 for my coefficients of x when I factor it. That's my f and my g. So I just wrote these out. I know they're both pluses because everything was plus in the original, so everything is plus here. So I know those are pluses. And I know I've got a 2x and a 5x, not the 10 and 1, because those didn't work. Right, so I just wrote those down. Now I need to know what goes here and what goes here. And it's going to be 2 and 3, but which one goes where? Well, this 2 is being multiplied by this blue 2. You never multiply 2 terms in the same factor, so that this blue 2 has to be in the other factor. So it has to be over here. And that means the 3 is over here. Okay, so you write them in there. Now, you're not done yet. What you're going to do is check your answer by multiplying the right side out. And you can just do this in your head, unless they're more complicated numbers. So you go, okay, to get this x squared term, I have to take 2x times 5x. That's 10x squared. So that checks. To get the 6, I need the constant times the constant. So that's 2 times 3 is 6. So that's right. So the only thing that can be wrong is the 19. The 19 comes from the middle and the outside. So this is 15. 15x plus 4x is 19x. That checks. So then I would put a box around it, and then I would input it in the calculator. Okay. So you should, when you're inputting these, you should know that they're correct. You shouldn't be guessing that they're correct. So that's one good thing about this factoring is when it's right, you'll know it's right. So what I actually write down is I don't actually write out all of this stuff here. This is just so you could see what I was doing, right? What I write is I just go like this, and I try them all, and then I just mark the ones that work, like this. And then I go down here, and I write this out, and I write this in the way I showed you, using these numbers, 2, 5, and 2, 3. Then I multiply it out to check it, and then box it if it's right, and figure out what's wrong, what I messed up if it's wrong, and then input it into the computer.